Hi there. Happy Monday. I apologize for not being in class today. Um, Feeling pretty awful. But I didn't want us to get behind, so I have posted the notes for 8.2, continuing on with this chapter 8, Consumer Math, where you can click on this and print out the notes to follow along. Maybe it'll come up. Um, Print out the notes and follow along with this video so that, and there's a little assignment at the end for you to figure out. So hopefully you'll be able to complete that before Wednesday when we meet again, and that will be for turning in on Wednesday so that we don't get behind. All right, cool. All right, so let's get started. So 8.2, 8.1, we started talking about interest and percentages so that we could talk about interest. That is finding the percentages of numbers and numbers that are a percent of a number. So this next section is on interest, which heavily uses percentages. Okay, so by the end of this lesson, you should be able to use a simple interest formula. Um, to solve some problems, use the compound interest formula. So we have two different, sorry, I'm just trying to remember how to use my little annotated thingy here. So we've got the simple interest formula, and then we have what's called the compound interest formula to find future value if we were, excuse me, to deposit some money into an account at an interest rate for a specified amount of time to see how much it would grow. All right, so Albert Einstein said the most powerful force in the universe is compound interest, but only if it's in our favor. Well, it can also not be in our favor, and that would be bad. All right, so here's our simple interest formula. It is I equals PRT, where I is the interest earned. P is the principal, which is the money we either deposit into an account or that we owe on a loan. Um, and the rate is the interest rate that is earned or owed. And then the time is in years. So for instance, if I were looking at interest over a 9-month period, that would be 9 and 12 months, since 12 months in a year. So that would be 3/4 the time. So we be careful with our time always being in years. Okay, so calculating simple interest. Here's an example. If you deposit $500 in a bank paying 6% annual interest, how much interest will the deposit earn in 4 years if the bank computes the interest rate using simple interest, which is the formula that is right up here. So to begin, I always recommend starting out by writing out your formula that you're going to use. And I like to do that because then I'm just filling in these values for the known things. And what is it asking? It's asking how much interest. So we're going to be looking for I. Um, and then also, what are the other values? So labeling those. I is what we don't know. P is our principal, and that would be the amount that we deposited. That would be 500. Rate is 6%, but we always look at the rate in a decimal. So that would be 0.06. That's what we just looked at the other day. And then time is in years, it is 4. So now I can just fill in what I know to find what I don't know. So that would be I equals P is 500 times 0.06. And actually, I'm going to go ahead and put parentheses because that's the proper way to do it with algebra, and also entering in your calculator. Parentheses are going to be your friend. And that is times 4 years. And then I just use my calculator to determine that the total amount of interest I will earn in 4 years would be $120. So make sure that whenever you use your calculator, you can arrive at the same values that I arrive at. And so if the account earns $120 in interest at the end of that 4-year period, at the end, this isn't part of the question, but it will be, at the end of the 4 years, how much money will we have? That looks terrible. Okay, so that would be the original that we put in plus the $120 that we earned in interest that the bank paid us to hold on to our money. And then we would have a total of $620 at the end of the 4-year period. So that's kind of how the interest works. And um, yeah, so let's go ahead. See, try to remember how to clear my clear all drawings. Okay. All right, so moving on, the future value using simple interest. So that is what we kind of just determined when we added the 500 plus our $120. That's what this formula is, but we're going to change some of the labels, which can sometimes be a little bit confusing when you make changes like that. Okay, so the future value using simple interest is given by the formula A equals P times 1 plus N. So if we're adding our principal plus our interest, and our interest we knew was from the formula before, PRT, um, then that would be let's see, A is our future amount. This is our future amount that we're going to have after we deposit some amount of money, and then we multiply it by our interest to figure out how much interest we'll have. But the multiplied by 1 is just the principal itself. So that's the amount we deposit, and then adding to it the interest, which with this, we're going to calculate N as the rate times time. So we're kind of putting in the rate times time together. So that's where this kind of RT is right here. You can see I put the labels right here. So it's the principal one time plus the principal times the RT, which is what we just did a second ago. So, but this is the formula that we would normally use. It's still simple interest, just looks a little bit different. So you're going to have to remember all of the little labels that are used for these formulas. And on like a test, you would always be given these formulas. All right, so find the future value and the present value of an account. So the future value, suppose you deposit $1,000, that would be our P, in an account paying 3% interest, that would be our rate, 0.03. Oh dear, for how many years? Let's see. See if I can find this example. Oh, for 6 years. That is supposed to be 6 years. All right, I'll go ahead and make that correction. 6 years. Calculate the future value of the account. So future value I know is A. So I'm going to write A equals P times 1 plus N. So I'm not given N, or I didn't find N. I found T and I found R, but N is when I multiply these two things together. So A is our unknown, P is 1,000, 1 is itself, and N is equal to R times T, which is equal to 0.03 times 6, which is equal to 0.18. And if the decimal ends, we can go ahead and put that decimal. If it doesn't end, we don't round. We would just put these values in. So A is what we're looking for. Principal is $1,000. And then I'm writing it exactly how I would be typing it into my calculator. 1 plus 0.18. So go ahead and use your calculator and see if you get to 1180. So that would be $1,180. That would be the future value of this account. Okay. Now let's go ahead and look at present value. So you plan to save present value. That means it's still P. Let's see. Present value is the amount we deposit. So it's basically like calling principal, uh, the principal amount that we would deposit right now to have a future value, um, now to have an increase in the future. So we're just going to have to use a little bit of algebra to solve for that. And it's not difficult. And it might be easier to see if we just go ahead and substitute in some numbers. So we plan to save this much money. So that's going to be our A. We we want this much in total to take whitewater rafting trip on the Rio Grande River in New Mexico in 2 years. Your bank offers a CD, which is a certificate of deposit. It's just a fancy little savings account that holds your money for a certain amount of time, maybe 6 months or a year. The interest rates are usually a little bit higher than a regular savings account, if you're not familiar with those, but you aren't supposed to touch your money for the length of time. And if you do, there's a penalty. So you basically don't get any interest if you take it out ahead of time. It's a good way to hide money from yourself and not be tempted to touch it and let it grow. Anyway, it pays 4% annual interest computed using simple interest. How much must you put in this CD now? That would be present value to have enough money in 2 years. So P is what we're looking for this time. Our future value, what we want to have is 2,500. Our rate is 4%, so we'll call that 0.04, and our T is equal to 2 years, but remember N is what's in our formula, and that is R times T, so that is 0.08. And again, if we write out our formula just above where we include our values, it's it helps us put them in the correct place. So first we determine what our values are for each of the labels, and then we write out our formula, and then directly underneath we go ahead and make those substitutions. So A is 2,500, P is our unknown, and then we have multiplied by 1 plus N, which we determined is 0.08. Okay, so now what I see here is that P is what I want to solve for, but it's all being multiplied by this other stuff on the other side. So just remember how we undo multiplication, and if it helps you to read something out that says 2,500 is equal to P times all of this stuff in the parentheses. So if it's multiplication, I know that I just undo that with division. And I have to do it to both sides to keep my balance. And then this whole amount divides out. And so then what I'm left with is P equals 2,500 over 1 plus 0.08, which is equal to, and sometimes we may get an approximation. Sometimes we may have to cut our decimal short, divided by 1 plus 0.08. And I want to be careful here because I want to, when I put this in my calculator, I want to be careful to make sure I use parentheses because 2,500 divided by 1 plus 0.08. If you don't use parentheses, your calculator won't know to divide it by the entire thing on the bottom. It will use order of operations, and division comes before addition. So be sure to use parentheses whenever you put it in your calculator. Do it just like so, unless you have the ability to enter in fractions. And then we get, let me go ahead and use my squiggly equals because I have a long decimal, 2314.8148. And so I'll go ahead and shorten that because I'm talking about money. I will need to deposit $2,314.81 into my account, or maybe we round up just to guarantee we have just enough money. Let's round up, um, even though this really wouldn't have had rounded up to an extra penny, but always round up when you're saving money. And then you'll make sure to have enough whenever you need it in the future. Okay, so what does this mean? Going back to our question, how much must we put into our CD right now to have enough money in 2 years? So if we deposit $2,314.82, we will be sure to have $2,500 in 2 years. So how much money did we earn in interest? Let's see, take the difference. And we earned $185. Doesn't seem like too terribly much, but it is over 2 years and it's not that high of an interest rate, so it's not terrible. And it's free if we just leave our money sit. Okay, let's move on. The section won't take too long. Um, there's just one more little page here. Okay, so compound interest. Now, what we just looked at was what is called simple interest, um, where you're only given interest like at the end of a period, and it's compounded it's figured out very simply. That's why it's called simple interest. But typically, money is compounded. So it's compounded. Um, And what that means, okay, so here's a little thing. It seems fair that if money in the bank account has earned interest, the bank should compute the interest due, add it to the principal, and then pay interest on this new larger amount. So like say you deposited $100 and at the end of the month you earned 10% interest. Oh, that's very generous. You would have earned $10. So at the beginning of the next month, you would have $110. So then the bank has to pay you on that money that's in your account. So then the next month, instead of only earning $10, you earn 11 because 10% of 110 that you have now is a little bit more. So if you leave that money over a long period of time, that's what's compounding. So that means you're getting paid interest on the interest you've already earned because the bank is still holding that money for you and they're still paying you to hold it. So interest that is paid on principal plus the previously earned interest is called compound interest. And um, if the interest is added yearly, we say it's compounded annually. And if the interest is added quarterly, we say it's quarterly. And there are 4 quarters in a year. So that means it would be compounded 4 times a year. It can also be monthly or daily. And in fact, most things are compounded monthly or daily. For instance, your mortgage. Whenever you own a mortgage or owe money, or if you have a mortgage, if you um, on a house or even a note on a car, that interest is compounded daily. So the earlier you pay your note, not waiting till the due date, that's that many days of interest you aren't paying. So one way to pay off notes faster is to pay earlier or even multiple times in a month instead of just once a month. Something to consider, which we'll look at more in the future. All right, so suppose you're saving for a large purchase. You deposit $2,000 into an account that pays 10% um, annual interest, compounded annually. So that just means one time a year. Use a table to determine how much will be in the account after 3 years. All right, so here's how we would do that. Um, the first year we put in our principal amount, that's $2,000, and then 2,000 times, uh, oh, this last column is what will the value be at the end of the year. So this is not computing the interest. The interest is only 10%, which of course would be $200. Um, but when I say 1.10, that's telling me I'm multiplying it by 1 so that I get the entire $2,000 included in the total amount. So when you multiply 2,000 times 1.1, 1.10, you get the 2,000 plus the 10%, which would be 2,200. So now in year two, I'm going to start off with $2,200. And we'll do the same thing. We'll multiply that by itself because it's still going to be there in the end, plus 10%. And will the interest still be $200? Um, this time, my interest was $220. So my total here is 2420. So what I mean by that, just to clarify in case it's not clear, 2200 times 0.10 is equal to $220. And when I add the 2200 that I started out with, that's where I get the total amount 2420. So we're just including that in the 1.10. And now we're going to drop that down into our third year at the beginning. That's what we have, our principal balance, our principal amount. And 2420 times 1.10 gives us 26.62. So you can see that the amount grows each year. So this first year, I got $200 in interest. The second year, 220. And then in the third year, it went up more to 242. So what do you expect is going to happen if you leave that money alone for a long time? Um, what do you think is going to happen? It's going to continue to go up. The interest amount that I get each month is going to go up, or annually rather, it's going to go up and up and up. And so that just increases your savings power, which is why Albert Einstein said compounding interest is one of the greatest forces. All right, so this is easy enough to calculate for a short term, but the process would be way too tedious if we were to try to calculate it for a long time. So longer terms, we're going to use a special formula called the compound interest formula. And notice this formula um, looks a little bit different. It's similar, but it is slightly different in that it has an exponent on it. Okay, so also we're going to include this this value m. So a and p are still the same, right? But this time we replaced where the n is by r over m, and that includes the frequency of compounding. So our interest also, it's not written this way in this book, but in other textbooks it is written just as interest. And so our interest amount is the same as that rate over how many compounding periods that we have. So like if I'm looking at semi-annual, how many times does that mean will be compounded in a year? Because it is still yearly, it's 2 times. So in this case, m would equal 2. That's what we mean by the compounding frequency. So let's use the compound interest formula to determine how much will be in the account that we looked at above after 30 years. So that principal was $2,000. We are going to start at the very beginning to show. Okay, so the rate, what was the rate? Let me take this off. Let's see. Rate is, I already forgot, 10%. Oh, that was a high rate, right? 10%, which we convert to a decimal. Um, let's see. M, because it's compounded, how often was it compounded? It was compounded annually, so that means only once a year, which is not typical, but that M would be 1 since it was annually. The time is now 30 years, and N um, is now is still M times T. It's going to be the total number of compounding periods. I should have included that on here. Total compounding period. So how many times does this get compounded? And for us, since it's only being compounded once a year, that's going to be equal to 30. But typically you would be talking about monthly. Like think about your car note. For 5 years, you do it, or whatever. Say it's 5 years and you pay it every month. So that means your interest is compounded 12 months in a year. 12 times a year times 5, so it's compounded 60 times. So that would be your N. But in this case, it's just 30 because our M was 1. It's only being compounded once a year. So now let's write our formula. And we're looking for A. I forgot to write that down because we want to know how much will be in the account after 30 years. So we're looking at the future value. P equals, oops, not equals, P times 1 plus R over M to the N. So A principal is 2,000. And this is, now notice this exponent, the entire thing is being raised to a power. Okay, so we have to be careful. 1 plus R over M. So in this case, it's quite It's quite straightforward um, because m is 1. So, but still, just to write it, we'll go ahead and write it that it's 0.10 plus 1, and that is raised to the 30th power. So go ahead and see if you can use your calculator um, to get, let's see, I get 34,898.8 8045. So we'll just go ahead and call that 80 cents. We're not going to round up for that because the bank's not going to give us extra. So make sure that you can obtain this in your calculator. And if you need help, let's see, there is also a little button if you didn't get that in your calculator. Um, let's see. Make sure that you, well, in this case, it's not going to make any difference because we just divided by 1, but let's see, undo that. And um, sometimes we add in an extra set of parentheses in there. And then also, if you have a place on your calculator to put an exponent, that's fine. If you don't, you use the little symbol that looks like a little upside down V. That's called a caret, and it's on usually on all the calculators. And that is the caret is an exponent. So when you add that caret, it raises the entire thing to 30th power. So with only $2,000 after 30 years, look how much that grew. And so imagine what would happen if we kept depositing money into it, which is like what a retirement account looks like. All right, so one thing that we want to be interested in, and sometimes it's rather tempting. Have you ever seen a billboard that said no payments until 6 months or a year or whatever? And unless it says no interest or unless they tell you they're not going to tack on anything else, um, they're still charging interest. So be sure to be wary of those kinds of things. If it's still charging interest and you don't make any payments for 6 months, this compounding effect, like we did with savings, also works whenever you owe some money. So whenever you take out a loan, that interest is also compounded. And if you don't make any payments over a 6 month time, then all of that compounded interest is tacked onto your bill. So be careful with those kinds of things. So let's find out how much interest is accumulated in, for this case, a 6 month period. So you see an ad for a new car that costs $22,000 and it offers no payments for 6 months. So the payments don't start away, but the 8% interest does. And if you're buying a car, that I think is pretty close. That might be a little bit higher. That might be a little high now, unless it's a used car or unless you don't have a very good credit score. But we'll go ahead and say 8% because inflation, excuse me, inflation. Anyway, determine the accumulated interest for the 6 months you make no payments. So we want to know how much interest is accumulated when we make 0 payments. So an easy way to do that would be to consider or to calculate the future value of this principal amount because it works the same way whether we're saving or whether we're taking out a loan. So if we find the future value, then we can just take the difference of that between the $22,000 that was original. And that would be a good way to calculate this. So our principal balance is going to be the amount that we take the loan out for. It's for 6 months. So that is, remember, in years. So 6 divided by 12 would be a half a year, zero point 0.5. Let's see, our rate is equal to 0.08%, and we're not going to make any payments. We've got to calculate N, which is M times T, and oh, how much is M? M would be equal to, we're going to make a payment every month except for the first 6 months. So M is still 12. Okay, so that's how many, that's the compounding frequency. Compounding frequency, even though we're not finding this for the entire year, that's how often it's compounded in a year. So it's compounding frequency in the year, which is 12. Okay, so now let's go ahead and write our formula out. 1 plus r over m, and then that is all raised to the n. So A is what we're going to be looking for. Principal amount, 22,000, and that would be 1 plus R, which is 0.08 divided by 12, and that would be raised to the n power, which is, 12 times 0.5, so that would be 6, because that's how many times, that's the number of compounds for this particular, the number of payments or compounding periods in our time frame. Okay, so that would be, use my little caret there, and I might have to add in parentheses. Oops, I was going to put that in a different color so it stands out. Okay, so add in an extra set of parentheses there whenever we use our calculator. So go ahead and grab your calculator, and we're going to type in 22,000, open up our parenthesis, 1 plus. I'm going to open another parenthesis for that, that fraction that's in there, 0.08 divided by 12. Close both parentheses, then use my caret, and that is 6. And oh, that's not right. I put in a wrong value. Okay, I'm starting over. 22,000. You can't put in a 2 where there's supposed to be a 1. That makes a big nasty difference. 1 plus 0.08 divided by 12. Oh, that's better. Okay. Um, all right, so I got 22,894.797, so we'll round that to 0.80. So then how much interest was accumulated? How much interest was accumulated during that 6 months? We went from $22,000 note, and by the end of the 6 months, when we start paying our note, we now owe, looks like an additional $894.80. So while we were saving money over that 6 months, not paying our note, the interest was just accruing. And so the interest paid, interest accumulated that we still owe is that difference between those two numbers. So when I subtract 22,000 from that, that's what I got. And that would be tacked on to the end of your bill, and you would still owe, and that would kind of suck. Okay. All right, so hopefully this is all making some sense. Using these formulas. Here are a couple of tasks, and I'm going to go through the one, but I'm going to leave the other two for you to do on your own, and they will be to turn in on Wednesday. Make sure that we get those done so that we can stay on task. All right, so finding the present value for a college tuition account. And this is just a practical thing that parents usually think about. Maybe not super young parents, but older parents certainly think about it. How are they going to send their kids to college? So one way to do that is to let some money generate compound interest to grow. All right, so and this one says, upon the birth of a child, a parent wants to make a deposit into a tax-free account. So that would be like, well, in some cases, that would be like a traditional IRA where you don't pay your tax on the money that you deposit in now. You pay it later whenever you take it out, but that's a retirement account. There are accounts that are set up similar, and they are specifically for the use of college. Which is what this one is, to use for a child's college education. So the account offers 4.8% interest compounded quarterly. How much must the parent deposit now so that the child will have $60,000 at age 18? So how much will the parent deposit now? We are looking this time for P, the present value. That's our unknown. And we want our future value to be 60,000. Our time is, I guess it's 8 years. Oh, because the child is just born. So at it's 18 years, not 8 years. 18 years. So at age 18, upon the birth, so we kind of have to figure that out on our own. The rate is 4.8, but we call that 0.048, right? So just be careful. 4.8% interest should look like 4.8 cents, right? Um, let's see, what else do we need? We need M. M is how many compounding periods per year. So that is determined by this part right here where it says quarterly. So M is 4. So N, remember, is M times T. So how many compounding periods will there be in the life of this account? So there will be 4 a year times 18 years, which gives us 72. So there will be 72 total compounding periods in um, this whole this whole thing. Okay, so what else did we need? We need our interest, and that is R over M. So we'll go ahead and add that in. Um, these two things right here, R over M, is what we sometimes call interest. So that would be 0.048 divided by 4. And that's this, these are two equivalent ways to say the same thing. R over M is I. So let's go ahead and write out our formula. A equals P times 1 plus R over M, or I, and that is raised to the nth power. All right, so now we can start to fill in our known variables and also our unknown. So A, how much we want in the future, 60,000, is equal to P times 1 plus 0.048 divided by 4, and that is raised to the nth power, which is 72 compounding periods. And notice again, we're in this situation where we want to solve for P, and P is being multiplied by this stuff in the parentheses, which is being raised to that power. So it's just as simple as before. We only need to divide out whatever P is being multiplied by, which is all of this, this entire other thing. I don't like the way that looks. Okay, there we go. Um, and I don't know if this will, yeah, this whole thing is going to be divided out. So let's go ahead and divide that out. And that would be 1 plus 0.048 over 4. And then I have to do the same on the other side. 1 plus 0.048 over 4. And then what happens is all of this goes away, and I'm just left with the P equals 60,000 divided by 1 plus 0.048 over 4 raised to the 72 power, all on the bottom. So it might be easiest um, to calculate the bottom number first and then go in and add the top divided by your most previous answer. There's usually a button on your calculator to calculate for your previous answer. So 1 plus 0.048 divided by 4 raised to the 72 power gives me quite a long decimal, and I do not want to shorten the decimal. Do not round decimals until the end. Because if I round them in the beginning, it will change my answer in the end. So what I can do is just calculate that bottom number, which I get as 2.360461386. And I don't want to shorten it. If I don't do anything, if I don't clear or press any other buttons except start typing in my, um, please excuse me. Um, so this bottom number, here's what I'm trying to say. This bottom number gives an answer, right? So then I'm just going to leave that alone and I'm going to type in 60,000 divided by my last answer. And if I do that, there may be a shift key on your there may be a shift key on your calculator where the answer is just under one of the buttons, or it may have an answer key, but you'll have to look at your particular calculator to see how that works. But when I do that, it recaptures that answer that I had previously so that I don't have to type it in again and I don't lose any of the decimals. Um, and if you do that, you should get 25,418.75759. So I'm going to go ahead and round that to 76. And that is how much money I should need to deposit into this account at 4.8% interest compounded quarterly for 18 years. And if I deposit that amount, it will go, it will, in its future value in 18 years will be worth $60,000. And I should, in theory, have enough money for college, except we don't know what inflation is going to do. So we can't be too sure about that. All right. So hopefully that gives you some ideas of where to start. The two problems that are on here, buying an entertainment system and buying a car. Um, you have purchased a home entertainment system for $3,600 and have agreed to pay it off uh, in 3 years at $136 per month. You don't even have to do too much work. We're just finding out what is the total sum of your payments and find out how much interest you paid based on how much you paid overall and how much you originally agreed. So, so this amount you pay to get your total sum of payments, and I'm assuming we're going to assume we're going to pay this off in 3 years. So it's going to be once a month. So 12 months in a year times 3 years, that's going to be 36 payments that we will make at this amount. So how much is the total sum of your payments and what will the total amount of interest you paid? So you actual paid and what minus what the original amount was. And then the next one is a similar task of buying a car, which may be more like something you might want to do. You've purchased a used car for $6,000 and agreed to pay 24 monthly payments. What's the sum and what's the total interest you've paid? So be able to calculate those. And I look forward to seeing you on Wednesday. Have a great day.